Let's now talk about the influence of propellers on roll stability and trim. And so let's start off with stability. So here's the main wing and then a horizontal tail. And let's put a propeller up here. And now let's put this aircraft at some side slip angle beta. Okay, so we've got some velocity here coming in from the right-hand side. What happens with the slipstream is that the slipstream from the propeller will get deflected in the direction of the free stream velocity. And so you can imagine now, and this deflection happens more at lower speeds because you have a smaller forward velocity. So any side slip velocity can have even a larger effect on this than when we're up at altitude. You have to have a fairly significant side slip velocity up at altitude and up at speeds, at normal cruise speeds, to have a significant effect here. But at low speeds, a side velocity can have an impact here because our forward velocity is rather small. So anyway, what happens is the slipstream gets shifted to one side or the other of the aircraft. And so what would happen here with positive beta, for example, is that the dynamic pressure on the left-hand side of this horizontal stabilizer would stay the same as it was before. Roughly, if we say that the slipstream velocity is constant in there. So anyway, but on the right-hand side of this horizontal stabilizer, we're going to have a decrease in lift simply because we have a decrease in dynamic pressure. And so because of that, we actually are going to get a negative rolling moment. So I'll just draw that in here. So we'll get a positive rolling moment with positive beta. And so that's a destabilizing effect just from that slipstream shifting to dominate one side of the horizontal stabilizer instead of the other. And basically we're losing dynamic pressure on a portion of our horizontal. And so that's a destabilizing effect. Okay. So that's, this is a very complicated effect, and you would need to run like high fidelity CFD or really nice wind tunnel tests in order to capture this effect. So really, this is something that's basically kind of neglected in the early stages of design, and something that we just kind of account for later if it becomes a problem. So another thing I want to mention though is trim. From a propeller. And for this one, we're going to look at the front of the aircraft. So from the front, we're looking down the fuselage of the aircraft. There's a main wing. And let's now put a propeller on here. Then let's say that propeller is rotating. It's a right-handed propeller. So if you put your thumb out of the page here, it's rotating to the right. And we'll say that it's rotating at a rate of omega. Okay, so that omega is going to the right. Well, that creates a slipstream behind it that is also moving in the same direction as that, with the same rotation, in the same direction of that rotation as it moves down the slipstream. Okay, so that's inducing a flow field behind it in the slipstream that is also rotating to the right, according to our right-handed rule here. Okay, so what happens is that actually increases. So let's say that this wing were at 0 degrees angle of attack or something, so we don't get any lift other than what the propeller is creating. Really, this lift distribution that I'm going to draw here would be added to your global lift distribution. But basically what happens is you get an increase in lift on this side of the aircraft and a decrease in lift on this side of the aircraft. So and that's just simply to the induced velocity there, that's coming out of the slipstream. It's increasing the lift on the one side and decreasing it on the other. And so that's going to create a rolling moment in this direction. Okay, that's actually a positive rolling moment. All right, so for positive rotation rate, we get a positive rolling moment. But one other moment that is being created by this propeller is actually just the reaction force on the aircraft due to the torque required to turn the propeller. And that torque actually is acting in the opposite direction. So let's draw the torque in that direction. In order to rotate the propeller to the right, that creates an equal and opposite torque back on the aircraft in the opposite direction. And so that would be creating a negative rolling moment. Okay, so we have a positive rolling moment coming from the aerodynamics. So that's our positive rolling moment, and a negative rolling moment coming from the torque. And so that's kind of nice because they cancel each other to a certain extent, right? So usually the torque is a bit stronger than the aerodynamic rolling moment, but in some instances you can get enough aerodynamic rolling moment due to that change in lift on the wing to counteract the torque. Now there's one more thing going on back here, and I'm going to draw it just a little bit above back here just so we can see it. We've got so much going on. But if we have a vertical stabilizer back there, that's also due to this, just simply due to the wake, the rotation of the wake. It's going to induce some lift distribution that looks like this. And actually that's acting in the same direction as the rolling moment, as the aerodynamic rolling moment. So it's contributing even more to this guy right here. So the change in lift on the main wing, the change in lift on the vertical, all due to this prop wash that's coming at it, counteracts a little bit the torque required to even rotate the propeller in the first place. Now, some of this can be overcome by simply using more than one propeller on the aircraft and rotating them in opposite directions, and then a lot of these effects actually cancel out because you have the same equal and opposite on the right-hand side of the aircraft as you do on the left, and so the aerodynamic and the torque effects would cancel out. But for single propeller aircraft, which are very common, this is something that you should be aware of. Okay, so this is just a brief discussion on the effect of propellers on roll stability and trim. And of course, these types of effects are fairly complicated and would require high fidelity CFD or wind tunnel tests in order to really accurately predict or measure what these effects are from the propeller.